Can you share with me your screen? Can you guys share your screen? John. Can you be able to share your screen so that we continue? Okay, there.
I'm having a network issue.
Okay, somebody's sharing.
I'm having a network issue. Could you give me some minutes?
Okay, it's okay. Who else can share their screen? I will only help you if you share your screen, please. Okay, I'll continue. So guys, we have looked at how to sketch and also how to extrude, and how to fillet the corners, meaning to round the corners. We want to, this is a very basic thing. We want to add some few features onto the sides and then we just print it. So yeah, then from there, then we are going to continue with the software. So I want you to, on the sides, I want you to click the front or the front side, any of the sides where yours was. So I want you to click any side. So, and then onto this side, you can create a sketch onto it. And on this side, you place, you draw a rectangle onto that side. Namna hiyo. So click any of the side and then draw a rectangle, a new sketch, and then onto that surface, create a rectangle. I'm here to help you. Go to the side, any side, front, any side. Yes, yes. You can scroll with your mouse. That's why you get a mouse. This one.
When I double screen, will you please just move the thing?
Then you can protect. Guys, can you be able to share your screens? Rashida, John, Sadiq. Okay. Okay, we will continue from there. So we've already managed to draw a rectangle onto the side. Okay, so you can finish the sketch. Those who have already done the rectangle, you finish the sketch. Click onto the green part, alafu itaonekana kitu kama hii. No, it's okay. Just click onto the side, any side, like click it on wrong side. And then click new sketch. Then I draw a rectangle. Make it it's good like the rectangle down. You don't need to make it very wide. Make it and then eventually you have a friend and friend. I want a surface on this like come up, not like a main. So you don't need to just break up the surface you can share. And this one was very big. It's like a window on a wall. It doesn't have to be very big, it doesn't if it's ground. But if you don't, it's like that. Just go and draw it of any dimension. It doesn't have to be big, it doesn't have to be too small. Different. Okay, maybe. When you put something on the bottom, you want to draw an instead. Yes, we might want to Once you do this, we want to learn something which is called extrude cut. To extrude cut meaning you are going to extrude, but you are removing the material. You'll see what it's doing. So come to modify. Come to modify. Sorry, it's not there. Sorry, it's just extrude, sorry. So just click extrude, then click onto that middle rectangle. Click onto the middle rectangle. Then I want you to rotate, you rotate your object so that it has this view. It has like a orthogonal view. Just know that you can be able to change the view using that bottom, that box, box in hapa. You can click onto it, you click onto it, and then you hold the mouse, or you click, you hold it, the trackpad, and then unaweza change you can do that. So you click onto the trackpad, and then you do this, or you click onto the mouse, and then you hold, and then you move it. Onto you move the trackpad, then itafanya hivi. So just change an angle namna hiyo, and then instead of extruding outward, you see you can do that. Unaona? You can do that, but then this time around you extrude it going inwards. So mtakuwa mnakata just like this window, you can cut through that 3D surface, and then you do it for -2. Do like -2. So itatoka hivyo. Those online, can you be able to follow what we are doing?
Yes.
I moved too fast. Okay. So click extrude, and then click the new rectangle which you had. So click on that, and it will have an arrow. Imemanage kuwa na arrow. Then drag it inwards. Drag it into the object. Don't drag it outside. Drag it inwards. Na itakuwa na negative something. Drag it into the device. or into the box, and then uweke hapo a value like 2, -2. Sasa itakuwa imeingia ndani. Have you managed to do that? So can you click onto this and then you run? Alafu ndani nataka mvile ndani ya hiyo box. So, good. Inafaa ikuwe na shimo ndani. Guys, I want you to see inside here. Remember, you can use your mouse and scroll to make your part bigger. So, kama muoni, you can use your mouse or you just use on the trackpad to make it bigger. Then I was telling you, you fillet hapa ndani. Sawa, so mkifillet unaivuruta hivi. Mnaona? Guys, look up, everyone, look up. So I have my rectangle, which I have that here side yenye nimefanya hivyo. And remember that you can, if you are not seeing a hidden part like that corner there. Mtu alichukua mouse yangu. So you can click fillet, and then you go to the box. Inside the box there, you do that, and then you drag it inwards. You do like 2, then you press enter. So I want you to do that inside. Namna hiyo. You can also change to this other side. There are those who even are doing something inside this nini. We are going to do something interesting inside there. Inside here, you also fillet inside here. You drag it to, then also this side you rotate your part so that you are clicking that line. That line joining the 2 parts is what you click. This line here is what you click. You drag it like that. Then you click enter. Then itakuwa namna hiyo. Have you been able to do that? Have you been able to do that? Have you been able to do that? Yes. So let's stop here. You can make this thing as complicated as you want, and we are going to continue, but we want to export this to the 3D printer and start printing. So at least I know everyone at least has something they have drawn, a 3D object. Kama una, carry up your hand. At least every team or everyone here. So I want you to, I want us to export it. And which format did we say the Cura was using? You remember last week, which format were we using? STL. So you export the file. So you come to File, Export. So you go up there, File, up here, File, where there is the new file, where we created a new project. You click Export, File, then Export. Then in the type there, export.stl. It's the cappuccino.stl. Yes, File, then then click, the file type is STL. File, then down there is STL, then Export. Those online, can you be able to, do you have a 3D image? Can all of you turn on your video on your own? Those online, can you turn on your video and your screen? Yes, Rashida ako hapo. John, washa kamera.
Ndio nawasha kidogo tu.
Sasa nyinyi mmekuwa mkitupeleka na maji. Omweri Sean na John. Aya, Rashida, share your screen. Rashida, share your screen nione kitu umekuwa ukifanya. Nice. Good job. Aya, mtu mwingine. Guys, you see what she has done, eh? Yes, she was following instruction well. Good job. Aya, mtu mwingine. John. Stop sharing. Thank you. John, share screen yako. Share screen, John. John alikuwa na network. Sadiq. Sadiq na Sean. Anyway, wamekataa. Guys, I request you to cooperate. If you want to join, or if you don't want, you just leave if you think this is a waste of your time. Okay, so guys, let's continue. Yes, just a minute, I'm coming. So Rashida, please export yours. So you go to File, then Export, and then you choose File, Export, and then you choose the file format, the file type there as .stl. So yes, give it some time. It's going to export the STL. And what do we do with the STL? What do we do with it? We slice it. You change it into G code using the previous software. So yes. So if once yours has done that, then you will go that process we have learned. So mine is complete. I can see it. Show in File Explorer. You click there. I have it in the desktop. I called it lesson 1. So I'll open the next is you open the Prusa, which we used last week. So once yours has finished, then you open Prusa Slicer, the slicing software we learned last week. Mine has exported successfully to the desktop. So I open Prusa Slicer. It's opening. Yes. So I want to export it. So file export, then after type STL. So somebody has listen to export. So you may export. Can you open Prusa and then you import it to Prusa? Prusa we used last week, and then you import that exported. Prusa slice. And then file import STL. Let's keep it there. So guys, here now we are going to import our STL into the slicing software, and then after that we slice it, and then we get the G code and print. So go to File, Import. This I know now you know how to do. Import STL, and mine is on the desktop. I called it lesson 1, and that is how it looks like. Mnaona? Yes. So to print many of them, I'm going to request you to give me the STL of at least 2-3 teams, then to work for printer moja. Yes. So give it a name. Give it a name like what not your name 2 or 3. You don't export the default. Nataka tu the STL, sawa? Na mtaweka ile STL for 2 or 3. Yeah. Save it as give it your name. If I have to give it for them. Give it. So the other tools, so these are just some of the things we use for building. We are going to learn them time what they are, but there are very simple things to grasp, like for cutting. So the other teams, that is, I was telling you, you need a memory card reader. Then you can copy that. No more flash. And I don't see you guys, you may copy out this. Niko na ya shida. Mimi niko ya. Guys, if we want to bring them there, when they home. There's one I give it your name. I don't go the problem is that I do copy networks equal yeah, niko na watu nafikiria hawa wengine wataweka kwa hiyo mimi kupatia yangu yani mnaenda kwa hii mkimaliza mwapee nani aliyekuja hii hivi that is all So nimepata na watu kadhaa hapa wenye hawajapata yao mweke kwa hii flash. So Rashida and the other guys, you'll share with us on the group the design STL if you want us to print it for you. Okay. So we want to combine all the four. Yeah, we want to combine, I think there are four, and then we print them on one printer there. The others will come and print on this other one. This other one has a small problem, but I hope it will, you'll learn a few things with it. So guys, we did this last week, but we are doing it again. For those who don't know, so we are going to start, and then you import STL. Then it's on this flash, which I'm calling boot E. So nilikuwa na Nick and Brian, Grace, then Sheila and the networks. Simona. Yes, all of you can see that, yeah? Then you open. I'm like importing all the four, okay? Then you spread them out. Ndio hiyo. Okay, you can see what we have there. Then what do you think we should do before we slice? There's something which we can do to make it better. What nini? Unaona yawa iko straight, eh? So you want it to be as flat as possible. Like if it is flat at the bottom, then it's easy. So we rotate this one, eh? So if you look, it's not straight. It's not like super straight. So you continue, you rotate it, you try as much as possible so that it is flat. So can you see it's not? Yeah. Okay, ndio hiyo zimeprint, eh? Yeah, zimeweka. Ngoja pale. Ulikuwa unasema you place hii. Hivyo. Haya, sawa. Simeona sasa. So we have all the four. I think even the other guys, nikiwafanya haraka naweza wa add. Please leteni na flash. Leteni na flash. Sorry, this other printer has a small problem and we may not have nini, eh? So so we are going to add, Rashida, you can also just drop us yours on WhatsApp if you want us to print with. Yes, one has joined. Peter Collins, can you share? Yes. Can you share with us what you have printed, what you have designed?
Okay, give me a few minutes.
Yes?
Give me a few minutes.
Okay.
Okay.
Guys, ilikopi vizuri? Ilikopi? Kwa hii flash? Haitokelezei hapa. Can you copy it on a normal flash disk and mlafu mlete? Mnaweza copy on a normal flash disk, hiyo STL. Nani wako na flash disk wape copy hiyo ama ndio hiyo imekuja. Sorry, haya mlikuwa mnajiita aje? Mmeita yenu aje? Just a minute, let me pick this. Matt ya huyu mwingine Evans Aya, so I can come here, import STL Matt Ian na hii shefu Emmanuel Brighton. Aya, so sijui mtajua yenu ni gani. Najua watu wengine theirs is unique. Sawa. Aya, so we do that, then we learn something new. Aya, namna hiyo, si ndio? You guys can now see, yes? So we are going to this Kevin. Unaona let covers. Aya, so we have for almost every team, okay? So what do we do now? We export, we slice, yeah? Kuna gani unaona iko vertical? Zimelala vizuri. Hii iko sawa. Okay, you can decide to, but iko sawa, bado ita print sawa. Then now you come to slice now. Yes, so you see how they are going to print, yeah? Then now we export the G code onto that same flash. We're calling it, then we call it Nairobi. You are Nairobi team. So, that easy. So we have everyone's design is on that flash, okay? So, so we want to take it to the 3D printer and start printing. So we are going to go to the printer there and start printing. So everyone, I think we can bring it here at the center. This is another problem, but we will see how this is. So so for those who are online, who want to see what we are doing, those who are online and want to see what we are doing, that is the control, that is where we are going to, everyone come out now and then you see. Initialize, meaning if you remove the SD card, then you come to print from the SD card from TF, and then we call ours Nairobi. Okay, so the first thing it will do, so you should have, I had printed something. Okay, then I want you to see now what it will do. It will start by hitting the bed, hitting our part.
Unmute. We can't hear.
Can you see what you are doing? Guys, can you see?
Yes.
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 We have loaded all the files and it's here, and it has started printing. Going to take us some time, but yeah. Okay, so that marks the. We should do like. Let's finish the slides kidogo. Everyone go to where you are sitting. We finish the slides and then we let it print. And then, yeah, we'll continue from there. Yeah? But it a print. Okay, guys, can you be able to see the screen? Can you see the screen?
Yes.
Mnazaona? So we are finishing the slides, and then after finishing the slides, we will just call it a day. So okay, hello everyone. So this is where we left. We said to generate the toolpath, what the machine understands is what is called G code, which is just, in short, it's the path where the 3D printer, the tool, or which is the head, which is going to, as it moves, that is the path it's going to follow. So to do it, we said you need the 3D model, which you can download online from Thingiverse, Tinkercad. We looked at how to download that last week, or you can design. We've been able to design a simple part. So you design that and you have it in STL file format. Then if there are problems, then you can be able to repair. Repair meaning you fill in the gaps which are there. If it has got some gaps, or if the shape is not correct, you repair it. Then we take it to slicing and generate G code, which we've done. So the next part is, I don't need to even do this now. 3D model must first be obtained from the CAD software or from the online repository. Already we've covered that. Then this is the CAD software, computer aided design. So there is online one. Those who are asking for a free version, if you like something free, there is something called OnShape. You can just write it down. Or if you have kids, you have your brothers, and you want them to play around, design something, they can go to onshape.com. So it's a free online software which you can use. So basically what it does is, it's a software which helps us in the creation of the 3D model. So you draw them part, and then you get the XTL from it. So it increases productivity. Remember, once you design your part, then you can now print as many as you want. So, yeah. Compared to if you are, for example, if you are doing this thing manually, if you are carving wood or if you are carving metal, then you see it's going to be very difficult. The measurement won't be correct. They want to be uniform, things like that. But with 3D printing, once you design, the designer, you can even improve the quality of your design. The quality meaning it's going to be very accurate according to the design, as opposed to if you were to do it manually or by hand. Then also it's used, CAD output is also in form of electronic files, which you can print for machining or other manufacturing processes. Then the repositories we looked at Thingiverse, my mini factory, GrabCAD. Basically, they are an online platform which people share their design. So they're excellent source for free to use 3D printing models. Certain repositories host 3D files that are already optimized for 3D printing, and we looked at those. So you can write them down, look at them. We had looked at Thingiverse last week. Then there is what is called STL. We were downloading this STL, or we were getting this STL. So what is that STL in short? Are you going to share the slides? Yes, yes, we will share the slides. Yeah, so the STL format is a file format used in graphics or in computing to show like an object or anything can be represented by a set of triangles. So if you look the second diagram, sorry. If you look at the second diagram, can you see it? That which looks like a cage. The computer or the softwares, they understand this 3D model. This is the 3D part, the first picture. This is the 3D part, but the computer understands it in terms of the, just like there as a set of triangles which are joined together. So the computer divides it into triangles. And this, triangle consists of 3 points. So which are joined together, 3 vertices which are joined together. So that is how the computer understands it. So all that is brought together into a file which is called an STL. So for a 3D model to be printed, the file must be converted to an STL file. It's necessary. Most files on online repositories already in STL format. So this step is ignored. So if you download it, it's already in STL. But if you are designing it, you remember how we designed with Fusion 360. You are importing the STL because that is what the 3D printer understands. Okay? The Stl conversion process decomposes the 3D model into a series of connected triangles. So you are having your file which you have designed. It is decomposed or it is converted. It's like it's being sliced or it's being divided into a set of triangles. Some small, some very huge. All these triangles are connected together, or they are interconnected to make up your 3D model. So you can be able to see this is the actual model. But how the computer understands it is a set of triangles which are connected together. And that is what consists of that STL file. So there are some errors. So these are the errors which happens due to design. If you design something wrongly, like we were having some, when we were designing, people were having a lot of challenges, extruding, doing what. So if you do that wrongly, then you might get some of these errors. So these are the ones that you need to correct. Okay, so is there any question? Any question? Okay, no question. So what happens is when there are redundant, mtu ana join from here. Yes. Mute. So please mute or just leave the call. So what happens is that there are when there are triangles which are not joining together, redundant, meaning here and here, right here, according to this diagram, the triangles are not being formed properly. This and this. So the correct way is they be formed like that. So you remove this line and this line so that you have the part like this. So with this, then the triangles are going to be sliced properly. Then bad edge is where the edge where two triangles are not joining together. Like this triangle and this triangle are not joined together. That's a bad edge. Then the second one is gaps missing. Like if this part was missing, so the triangles are not going to form. Inverted normals, like this line should be facing up if it's facing down. So these are in the design, and you may not understand it, but from the technical point of view, but just know that the STL can have errors if those triangles are not formed properly. Okay, yeah. And in that case, you use a software which is called Stl Repair. So what the Stl Repair does is, if you have downloaded a part and it was very crappy, so the guy who was doing it was not a very good designer, he just gave you something very crappy, which means if you print it, it will not come out well, okay? So you repair it. Those who know Blender, okay? You know how to repair, like if you have a design, like even someone's finger, but it's not clear, the finger is short or something like that, you can be able to extend it to make it more realistic. So that's the same way this software is repairing. It is not critical to understand all the potential errors that may occur, only that there are tools that exist that can be used to automatically fix them. So you don't need to know technically how all that is working, but just know that there are tools like Slicer, Simplify 3D, Netfab, which is used to repair the STL. But mostly here, since we are going to be designing, this error will less likely. This will happen when you import someone's work. Then those are the three softwares, Slicer, Cura, and Simplify 3D. You can check them out. Then slicing parameters, layers, and perimeters. So you know, the slicing parameters are just when you are slicing with the software, there are parameters which you set, meaning like the slicing height or the height that you want to print and all that. So the layers and perimeter section of the slicer is where the user designates how they want each layer to be and any perimeter to include. A lower layer height will result into a print that takes longer to print, but of higher quality. So if you print, you see this, every layer has a height. Tuko pamoja. We've said that as it goes one time, it prints a layer. So if you have a very fine print, like you tell it to be 0.1 millimeters, So what do you think is going to happen? Is it going to print faster or slower? Slower. If you have 0. Think of it like if you're building a house out of very fine grain or fine concrete, you may take a lot of time to plaster or even to fill the whole house. But the quality is going to be okay. It's going to be very fine. The quality is going to be high quality. But if you are having a course or you said that every time it prints like even 1 centimeter or 5 centimeters, it's going to print a very rough thing and it will take a shorter time. Okay. Yeah. So you want it as fine. But the machines are typically having a layer height of 0.3 millimeters, which is to be used with the 2 perimeters. So just know that the machines are somehow prefixed, and these are not the greatest machines. There are other machines out there which are even finer. Then slicing parameters, there is what is called infill. So infill is when you are having a rectangle, or when you're having an object whose inner part is hollow. You can see inside here this and this and this. The plastic that gets filled inside here, let's say you are making a box, okay, or this strap. This plastic which gets formed inside here, what do you think is their use? What are they used for? For support, okay? So that your part, remember you may need to print something on top of this part. So they're used for support to hold the part in shape and all that. So the infill percentage is how much plastic you are allowing inside there. This is like at maximum, like almost 190%. Then this one is like 30. So if you have it very high, then remember this part is unwanted. So by the end of the day or after the printing is done, then you are going to cut it out. So let me just show you an example. Oh, so I got some of the things that I printed, and you can see that here. So some of these are highlighting the problems that happens with printing and all that, and when there's a good print and when there's a poor print. There was some okay. So what happens is when you are printing this thing, you need to have support inside here. So it's going to have some plastic printed inside here. And then once the printing is done, then you can install. So those are what are called infill. This inside. Yeah. Yeah. No, the software automatically adds. Where do you set all those products? In the slicing software, tutaona. Okay. Then there is what is called skirt and brim. Skirt is when it is printing, like you'll be able to see there. There is the part which is attached to the 3D part. So, there is this. This is the actual 3D. I hope yes. I hope you can see. So there is the actual part which is attached to the 3D model. That is what is called the brim. And then the outer one, this other outer one, which is not attached to the 3D model, that is what is called the skirt. So, yeah. So when it's printing, these are placed by the software. Sometimes like the skirt is not placed. Sometimes they're placed. So the part which is touching the 3D part, the actual part, this other one, that is what is called the brim. And then the other one which is not touching is what is called the skirt. the brim is being removed when you are printing, when you finish printing. So once you finish printing, then you slice it a spatula, or you can even just do it with your hand, or you remove the base, then it just snaps off. So you separate it from the actual 3D print. It's weaker. It's much weaker compared to the actual print. Then support material. We've looked at support material, or what support material is. For example, if you want to print this model of a dog, to print the underbelly, like here, okay? Look here, and even the chin at this place, when the plastic moves around, then it will find there is no material here, there is air, okay? So it can't print. So what you need to do is, you can see this material is different from this one, okay? So this one is a slightly advanced material printer, which prints out of two material, like the Ultimaker. The Ultimaker example, I think we'll be able to use them. They use two materials. So this is the solid, the support material, and then this is the actual material, the red one. So, and this solid, this other one, it's usually made out of a weaker material. Even this other one, they print it weak, very weak, so that you can snap it or you can cut it very easily, or it prints it out of soluble material. So like this one, this white part is soluble. So if you, after you finish printing, you just dip it into water, then it's water.
Okay, so like in the quantity up there,
Yeah.
you see the whole logo below the
No, yes.
Now, in an instance where let's say you have a folder, there is a solid part, then there is a folder, then there is another solid part on top of it.
Yes.
For a printer like this one, you say it's not extrude soil material. Does it mean that when it reaches that point, you stop and you load a support material?
No. It will print this with the same material. It will print with the same material, but it will be weak. This part will be, they will be like, it will print like, like you see this curtain, it will just be a string of those material, okay? It won't be a 3D, the layers won't be, it's not dense. So it means after you printed it, you can cut them easily. So, yeah. So we'll print something here, or one of these. You have a question? Yeah? How? I can't hear you. Do you save the time? Yes, how you save the file is also. So just know that this in some 3D printers like Ultimaker, this support material is made out of soluble material. You wash it in water, you dip it in water, it dissolves, then your part remains, the red part remains. In the other printers, it's printed out of weak, it's very weak, and in that way, after the print, then you can just remove it easily. So, yes. Okay, then slicing parameters, the speed, you need to set the speed of printing, the temperature, the printing temperature and all that. So currently, there are generally 3 sets of printing speed that the printers can support. This first set can be grouped at around 40 to 50 millimeters per second. So the speed is how fast the 3D printer is like sucking the filament, okay? Remember, we are having an extruder here, and the extruder is drawing the filament in. So per second, it's drawing like 40 to 50 millimeters, or like 4 centimeters, 5 centimeters, okay? So that's the printing speed, the speed working on. So while the second set is much faster, it's around 80 to 100 millimeters per second. Meanwhile, faster prints of around Meanwhile, the fastest sent prints is around 150 millimeters per second. So if it is printing very fast, the feed is very fast, then it will print your part faster. So some printers may print up to a speed of 150 millimeters per second. That is very fast. Typically, faster 3D printing means lower quality. If you print very fast, the quality is going to be lower or poor. And then above 150 millimeters per second, the quality drops noticeably, and you may experience problems with your filament, which will slip at these speeds. So it will slip, meaning it's too fast, and the motor and the gear mechanism cannot be able to hold that printer. So on that printing element, filament, and then the print quality will be reduced, or it will even stop. Then there is the slicing parameters, the machine parameters. The machine parameters are those parameters which you input into the machine. So, yeah. And how did we say you can control this? This idea we are not. Okay. How did we say you can change the settings? You go to the control panel, okay, and then you put those settings. So, yeah, you can the settings which are there are like the dimension of the print bed, the bed that you are having, even the diameter of the print nozzle. The nozzle is where the plastic is coming out from. That is the nozzle. If you have a new printer, you will have to know what is the nozzle. That will dictate the 3D filament that you have. You cannot just feed a very tiny filament on a big extruder or even a bigger one. It will block it. So, yeah, so you have to know the printer that you're working with, and the bed. The bed is where you are printing on, and what is the length and times the width. Then the filament settings. The filament settings are the settings that are put on the machine, but that are related to the filament. For example, the temperature which the filament is working on. Then also the type, if it is PLA, plastic, or ABS. So typically, around 1.75 millimeters filament is used. Like this one is 1.75 millimeters, the diameter. So you put that into the filament, and then you use that for printing. So G-code, we have looked at G-code. You see now it's being generated. What G-code is basically the tool, the path that the 3D printer will follow. Like if it is printing, you've seen it printing. It's going to be following this yellow and red lines. So every time, so that G-code that you are having, it's basically this drawing. If you place it on paper, this is how it looks like. So yeah, that is what the G-code is, and it is layer upon layer. So if I share my screen, if I open Prusa slicer, and I'm sharing for the people at home. So file, I'll import something. One of the things which you guys have designed, or the one that I have designed. Ikikataa, you can start it again. Yes, just a minute. So if I import, file import, this now you know how to do. So yeah, so guys, look up. So this is our part. We are going to tell you those settings, where you can get them. You slice. So if you come here, ukikuja on your right hand side, there is the simple. I had already shown you this is what you do. You can do draft, fine with the draft, normal, rough, super fast. This is the speed at which you want to operate the printer. Okay? Yeah. And then if you come to advanced, there is the infill. What did we say infill is? Infill. Yeah, the support material inside the 3D printer. Okay. So you can change this, put it like 100%, 10%. Then brim, niliwaambia what it is. Okay. So if you come to slice, this is the slicing parameters. So you can be able to see, if I do this, there is this arrow which is there. You are going to see that is how the printing is going to be formed. No, like it's placing it layer upon layer. Naeka plastic layer upon layer until you get the final part. I think others may not be seeing it. Sorry. Those online, can you be able to see? Those online, can you be able to see the? I think I've shared. So this is, you can be able to change that is how the printing is going to happen. It's going to print them and they're layer upon layer, okay? So you can be able to change the infill to maybe 40%. If you do the 40%, your part is going to get damaged. So you play around with them. At around 10% is okay. Okay, so you can come to print settings on this other side. Hiyo ilikuwa plater. We were in the plater tab, but now we are going to print settings. Print settings are you put the height, the width, the height. Sorry, there is horizontal shell. Some of this you should not change them. Okay, but you are just getting that knowledge because they are already been set for that your printer. For this is Ender 5. So you should not change them, but if you are being a geek, you can decide to change them and you'll see how they work, okay? Yeah, so there is this, the layers and parameters and perimeters. Then there is infill. I've shown you what infill is, the plastic which is inside the part. Then there is skirt and brim. What's the difference between skirt and brim? Skirt is attached to the, yeah, brim is attached to the part, yeah, and then the skirt is the one outside. Then the support material, overhang, rafts. Overhang is, you remember like the dog, yeah? Something overhanging is, they're also just support material. How much, if you are printing, like if you are to print this house, then this roof is said to be hanging, overhanging. So you need to put all that. Then there is the speed. The speed is the travel speed, the solid infill speed, they're all that. Then there are filament related settings, like the filament color, the diameter is like 1.75. Density, the diameter is the Ender 5, the Ender 5 printer, that printer, this printer, it's around 1.75 millimeters. So that's the diameter of the tip there. The temperature you want it to work at 210 for the extruder where the plastic is coming out, and then 40 for the bed. So yeah, so hizo mnaeka hapo, or they're already set for you, so you shouldn't worry about that. What else? Cost, you can even decide to put if you are a money guy, you put how much per kilogram, so you calculate, unaanza kufikiria how much you're going to spend. Then printer settings. Printer settings are the nozzle diameter, layer height, extrusion offset. There is one thing that I want to tell you about, which is called retraction speed and detraction. Retraction is, remember, you are bringing in the filament. The extruder is extracting or is pulling it inward, okay? But when it pulls it, if it is too much, then it releases it. It moves by pulling it up, down. If you look at that machine very well, it's pulling the filament into and out. Just a minute. So, what we mean is inside here, this motor is pulling the filament inward, okay? But it cannot pull it continuously because it will clog here. So it's just pulling enough, or if it pulls excess, it has to return the excess, like in an includer and project. Okay? So when it returns it back, let's put first retraction. Are you together? Yeah, so it works by pulling it in the router and reducing it. Okay? So you don't have it just continuously flowing because it's controlled. Remember, some parts you just need small plastic. Some parts you need so much plastic. So the router, we can certainly so yeah. So that is what retraction is. I showed you the retraction is how much when it's pulling plastic back in and then releasing it. So you can put the speed, how much. Remember, we are measuring the speed of this machine in millimeters per second, which is the length of the material it's pulling, and then per unit time or per second. So yeah, so those are what you need to know about the printer settings. Okay, so those are what are G-code. I'm continuing. So how to slice or how to select slicing parameters. Yes, question? For example, yeah. When you finish another machine, yes. The same product. it will be very off. Yeah. Yes, these are the settings of this machine work well with this machine. If you bring it to another machine, problems will occur. You will have to know the machine that will bring your product for you to export it. Yes, yes. Yeah. If you buy a certain machine, you have to use that machine's printing for optimal. You can print something, but it will not be optimized. Yes. Yeah. We had looked at this. Okay, how to select slicing parameters. Okay, let's see. So this is the second last. You guys are going for lunch. Okay. So remember, when you are printing these parts, for them to not to break or for you to have quality printing, then you need to print them. Look here. If you are having to print them like this, going upward, okay, these are what are called the grains. I don't know whether some of you did woodwork. So what happens is it's easy to cut something, or it's easy for something to break if the force of action or the point of action is along these grains or these lines. So, okay. So if you are printing something, you should ensure that like when the lines are, these lines are straight like this. So breaking this part is very much easy compared to when they go like this, because at this point the force is perpendicular. It's not running along the lines of this. Do I make sense? How many of you worked with clay before to model something, or or wood or whatever. So we just know that if this part is going to have force applied on this direction, then the line of weakness is going to be huge because these lines are perpendicular, no, are parallel to the force being applied. So this will break easily compared to this. So look at how we are printing them. Like for example, somebody placed a sprint facing up, and then somebody placed a sprint facing lying to the wind. So that will affect how much, depending on how much force is going to be applied. So let me just read and explain to you. So you need to orient the part so maximum force is applied parallel to layers. See? So you have to have lower layer height, disable the cooling fan to increase the strength. You disable cooling fans, you create interlayer bonding, increase infill, and increase the number of perimeters. So if you just need a stronger part, then there are some of those settings, but the machine does them for you, so you should not worry. Then to increase the quality is how smooth or how soft it is. So like make it almost like if you are to print a phone, then you look at this one and the first one, the second one is much smoother, okay? And we are going to see when the printing is going on, some it will not be very nice. So what happens is you need to have the layer height. The layer height, remember, is how much plastic it's placing per layer. Okay, ikienda layer moja, then that is the layer height. You need to lower it. Then they calibrate the extrusion rate and also the speed. You need to lower the speed. You want it to print as low as possible. That marks the end. Then find real life product that you can print, that you can easily replicate using 3D printing. This is an assignment. So this is something that you will do at home. During this week, look for something physically at home. I think you will take its picture or you bring it with you. To say you bring it with you. So next time, yeah, next weekend, bring a bottle top, bring whatever thing a real life experience of something you want to print. Okay, then we are going to measure it. Make it slightly. Don't bring in something too big, something too small. So, like a watch, a wristwatch, a pen. Just bring something. Okay. Yeah, and then we are going to measure it. Use what you learned about the types of products that are printable and what types which are not printable. Identify whether the products are good certificate for building with 3D printer. Okay, we know what can be 3D printed and what cannot be. But what we will use them for is we will do what? We will reverse engineer, meaning we will make a copy of that part. So bring me a watch and then you'll go back home with 2 watches. So, yes, so that's it for today. We will continue from there. Rashida, Nasur, Peter, Ian, whoever, do you have any question? What were online?
No.
Yeah, do you have a question? Do you have a question? What one text?
It's Sadiq. I think I don't have a question right now,
Yes.
but maybe later on I'll ask you something. I'll inquire for some details if you don't mind.
Okay. So somebody was asking. You guys can also help. For Ultimaker, does it have 2 print heads printing the 2 different materials at the same time? The dog and the soluble material, and how does this happen? Okay. It has got 2 print heads. So you print on one and then you print on the other one. So it's just like this other one and it has 2 printers. But then there are also other printers which it uses 1 extruder. So it's just 1 extruder, but it has got 2 holes or 2 the where the extrusion happens. Okay. Yeah. Okay, guys. I think this marks. If you have any question, ask. So bring something. Okay. And think of it like medical. If you have a medical idea, the first thing which we will do next week, is we will be reverse engineering that part. So that you learn how to bring a plate or a cup, but something realistic. So I don't know what, like socket. Mnaona kama hii socket, this wall socket, that is something very easy to reverse engineer. Meaning we are going to measure the distance, length, what not, then we 3D print it. So yeah, so we'll bring that part, we'll 3D print it, and then we measure it, do all that, then we 3D print it. Or at least once we have designed it, then the 3D printing now will happen. So yes, then from there, you will start doing your medical. So that week when you go home, you are going to look for a medical solution and start printing. Yeah, yes, question? Perimeter is like around the part. Yes. Increase number of perimeters. Perimeters, ama. I'll share with you the slide then because just know that there are you there? E. Hi, up. Typically, a layer height of 0.3 is used with 2 perimeters. Okay. What means is we are going to see during the printing, like when for one layer height unaeka mara mbili. Yes, so that is the 2 perimeter. Yes. Okay, thank you everyone for attending. Those who are online, some of you are not very cooperative. Get good internet and share your screen. Sorry, because if you're not sharing your screen, then I can't help you, and I can't see what you are doing. You are just you're not being part of us. Okay, thanks a lot for attending, and those who came physically, and see you next week.
Thank you.